This video is going to go over Chapter 13, Objective 8, where we talk about how cerebral spinal fluid is produced within those ventricles. Not exactly too much in detail, but we are talking to mention production, how it moves through the body, as well as some diseases and disorders. So cerebral spinal fluid is described as a clear liquid that fills the ventricles in those canals, which would be your cerebral aqueduct of Sylvis. It flows in the subarachnoid space. So we mentioned that previously. It's produced by the ependymal cells, which line the inside of the tube in a single layer. So it's just a single layer of cells. This right here is your ventricle, which contains cerebral spinal fluid, and those ependymal cells are producing that fluid and dumping it into the ventricle, okay? So again, see that choroid plexus right there? It includes the ependymal cells as well as some blood vessels and stuff, and this is actually some pia mater right there as well. Produced by the ependymal cells, which line the inside of the ventricle in a single layer. Choroid plexus is ependymal cells, support tissue, pia mater, and blood vessels. The cerebral spinal fluid has three main functions. Its job is for protection. It acts as a cushion for the brain, limiting neural damage and cranial injuries. So it is just a barrier there to kind of help the brain from bumping up against the skull bones. Buoyancy: by being immersed in cerebral spinal fluid, the net weight of the brain is reduced to approximately 25 grams. You don't have to know that number. This prevents excessive pressure on the base of the brain. So it's floating the brain. It kind of keeps the brain from wanting to fall through the foramen magnum. And there are conditions where the brain is trying to squeeze through the foramen magnum. So that cerebral spinal fluid keeps it afloat so it doesn't do that. And then chemical stability. The cerebral spinal fluid is constantly being created, so it's constantly washing the outside of the brain, floating across the outside of the brain, keeping the brain clean and free of disease and things like that, and making sure the homeostasis is maintained. So you do have a handout in your packet on this one. So I encourage you to take a look at that. Now, it's a scary looking picture, I know, but let's just kind of go step by step and let's take a look at that a little bit. I'm going to pull the highlighter up here a little bit. So you're going to start at number 1, and this right here is kind of the summary, so it's kind of a shortened version. But if you take a look at number 1 and look at where it is right here, this is going to be your lateral ventricle. You can see that brown bumpy stuff right there. That's that choroid plexus. So number 1 is going to be this lateral ventricle, and you've got cerebral spinal fluid created by the ependymal cells within that choroid plexus. Follow the black arrow. That black arrow is telling you where we're going next. So in number 2, we're going to go into the third ventricle. So number 3 is that third ventricle right there. Notice that third ventricle. This is going to be around the thalamus area. And you can see again that choroid plexus, that brown material right there, which is creating cerebral spinal fluid. You can see the black arrows showing you that cerebral spinal fluid is being created from there. From there, it is going to go down the cerebral aqueduct. So you can see number 4 right there, that small little tube. That is the cerebral aqueduct, where cerebral spinal fluid is going to flow from the third ventricle to the fourth ventricle. So number 5 is going to be that fourth ventricle right there. And you can see, I was looking for the number on that. I didn't say fourth ventricle, but number 5 is the fourth ventricle. You can see the choroid plexus right there as well, which is adding to the existing cerebral spinal fluid. So again, you're constantly creating cerebral spinal fluid, which would make you think, if you're constantly creating it, you better have a way to offload it. Otherwise, you're going to have so much fluid around the brain that it's going to start putting pressure on there. So if you're creating it, you better have a drain somewhere. Now, from here, we're just going to go ahead and follow those black arrows, and we're going to go up around the brain. But you can also see that it's going to go down that central canal of the spinal cord, as well as in that subarachnoid space of the spinal cord as well. So it's going to go around the outside and the inside of that spinal cord. We're actually going to go up here to number 7, and we're going to follow that cerebral spinal fluid up and around, and it's going to go into that subarachnoid space. So you can see that this right here, this blue area, that is representing the subarachnoid space. Now, within the subarachnoid space, you have got these arachnoid villi. So right here, number 8 is this arachnoid villi. And what that does, if you follow the black arrows, you can see that that cerebral spinal fluid is entering into that arachnoid villi, which is where cerebral spinal fluid is going to be resorbed back into, well, I shouldn't say back, it never was there to begin with because it's just now appearing. So the cerebral spinal fluid is being resorbed into the venous blood supply. So it's going into the bloodstream. So if you wonder where plasma comes from, some of the components of plasma came from the cerebral spinal fluid that entered into that arachnoid villi. So it's kind of the drain, okay? So cerebral spinal fluid is formed by the corvoid plexuses and circulates through the ventricles down the central canal of the spinal cord to the subarachnoid space of the cord, spinal cord, and brain, up to be absorbed by the arachnoid villi of the dural sinus and enter into venous circulation. So it's not going into the arterial blood supply, it's going into the veins, which again, not a big deal there. It's just getting into the blood supply. So what if cerebral spinal fluid cannot circulate and drain properly? This can result in hydrocephalus, which is an accumulation of that cerebral spinal fluid on the brain because it has nowhere to exit. So again, you've got that brain with the large ventricles. It's putting pressure on the brain, which is going to be problematic. So if you wonder, why they measure babies' heads all the time, this is one of the things they're looking for. So what they'll do is they'll take a catheter or a shunt and siphon that cerebral spinal fluid off of the brain, have that cerebral spinal fluid go through a catheter and enter into the peritoneal cavity and drain it that way. Either way, it is still going to end up into the blood supply, okay? Not directly, not as directly as it would have otherwise, but it's still going to enter into the blood supply. So fluid buildup is going to cause increased pressure on the brain, which is what you don't want. Surgically draining the ventricles and diverting the flow of cerebral spinal fluid by placing a shunt. And this is a lifelong thing here. So this isn't a, we're going to place this as a baby and you're not going to need it anymore. No, people, sometimes that shunt or that catheter may get clogged. They have to go in and fix that. And it needs to be maintained. So they can tell when the shunt or catheter is no longer doing its job as it should. And I know two little babies that have had that done, and I want to say when they were 19, 20, something like that, they had to go in and have another surgery because there were some problems with the catheter. I mean, it's going to break down over time, and they just fixed the catheter and they're good to go again. They noticed they were getting headaches is what the problem was. So that's kind of what triggered them to go to the doctor and find out what was wrong. And that concludes Objective 8.